What's going on, everyone? You're back with Jono for another quick math lesson. Today we're going to have a look at the probability of cards. So the reason that I decided to make this video is that heaps of maths textbook have lots and lots of questions about the probability of cards, assuming that you know exactly what's in them. If you didn't play cards growing up or you don't play cards at home, it's something that's really hard to kind of wrap your head around. So just getting an idea of what's in a deck of cards and how these questions might pop up is really important in order to get these questions right. Because I'm sure you've got the maths ability to get these correct, but you might not know what the context is for the question. So a standard deck has 52 cards plus 2 jokers. But in all these maths questions, the 2 jokers are ignored. So we've just got 52 cards. These cards are broken into 4 even suits. We've got diamond and hearts, which are both red cards, and then spades and clubs, which are black cards. So half the deck is red and half the deck is black. And then each suit, which is made up of 13 cards, has numbers 2 to 10, and then a jack, queen, and king, and then you've got an ace at the end. The ace can sometimes be a higher value than the king or a lower value than the 2. It just kind of matters what game you're playing. But the maths questions will just say an ace, okay? So it'll be really clear to you what you have to look for. The important thing about the jack, queen, and king are they are royal cards, right? Because they're royals, kings, queens, jacks. And another way that you could see them written in your textbook is picture cards. And that's just because these ones have a picture, whereas the other cards have a diamond or a heart representing the value as well on that card. So for a lot of these questions, there are actually 2 ways to do it. And we're going to see how we can kind of skip some maths in order to get these correct. So this question is asking, hey, if I had a deck of cards and I picked one at random, what's the probability I'll get a diamond? So one way you can think about it is that, there's 13 diamond cards out of the 52. So my fraction would just be 13 over 52. But this can be simplified to a quarter and then you're done. But another way you could think about it, because we've got 4 even suits, right, that are equally likely to be pulled out here, if I just go, well, I need one of those suits out of the 4 that I have, you can just jump straight to 1 over 4 immediately and skip that math step. Another question could be, hey, what's the probability of pulling a royal card out at random? So because we've got 3 royals, jack, queen, and king, we know we've got 3 multiplied by 4 because there are 4 suits. So in total, there are 12 cards in the deck that are a royal. This means I've got 12 out of the 52 total, which are royal. And then if I simplify that, I get the answer 3 over 13. But another way you could think about it is because they're all equal, if you just find out one of them, it's going to hold over for all the rest of them. So if I lined up my cards 2 to ace, I've got 13 of them. And then 3 of them, jack, queen, king, are those royals. So the answer straight away is 3 over 13. Happy days. The next question is a bit more specific. What's the chance of getting a red 4? Well, because there are 2 red suits and there's only 1 4 in each of them, there's only 2 red 4s in the entire deck. So now I just have to go 2 over 52, divide both by 2 to get it simplified, and the chance of this is 1 over 26, right? So these ones are really easy when you're looking at specifically one type of card in a suit or in a color, because they do just make sense. Another type of question is having at least a 7. So again, I'm pulling out a card, and in this one, I'm saying that the ace is high. So if you just look at the sample space and write it out from 2 to ace, all you have to do is kind of understand or highlight the ones that are greater than 7, including 7, because it says at least. So that is 7, 8, 9, 10, jack, queen, king, ace. So I've got 8 out of these 13, which are at least 7. One way you could do it is that you could take these 8 cards multiplied by 4, because there are 4 suits, and find out there are 32 cards that are greater than 7 in the whole deck. And then I'd just have to divide 32 by 52, and my answer would be 8 over 13. Another way you could do it is using the complementary probability. Because I'm looking for a number that's at least 7, right? That means I know that 2, 3, 4, 5, and 6 are not in this group. So all I would have to do is find the complement. Because there are 5 cards that are less than 7, the probability of not getting these is 5 over 13. If I do 1 minus 5 over 13, I get the answer of 8 over 13 as well. So any of these methods work 100% of the time. Last but not least, if you've got the probability of finding a number that's between 5 and queen, right? In this example, we are not including the 5 and the queen. It says in between these two. I just have to go 6, 7, 8, 9, 10, jack. So my answer is 6 over 13. Happy days. Again, you could work out how many cards there are in total and simplify back. But I think the easiest way to do it is just knowing, hey, there's 13 cards in this suit. If I find out what I need or my desired outcome, count them up, divide by 13, I'm going to be fine. So I know this lesson was actually pretty easy, right? There's not too much maths involved, but really understanding and getting a feel for what a deck of cards represents is really important. One of the best kind of homework things that I have ever given to students is just play some card games at home. See if you can get a deck, teach your parents a game, learn one off YouTube, and I guarantee it'll click in your mind really, really fast. Thanks so much for watching, and I'll see you later.